Our next learning target for AP Physics talks about understanding situations where mechanical energy is changed into other types of energy. So before we can look at this, we really need to understand what mechanical energy is and what the alternative non-mechanical energy is. So mechanical energy, we say, is energy that's associated with an object's motion or with its position. So this would include kinetic energy. It would include potential energy from gravity and potential energy from springs, or elastic potential energy are going to be the three types that we're mainly using in AP Physics, those three. And then non-mechanical energy would be things like heat and light and sound, nuclear energy, things along those lines. Chemical would be put in here. There we go. Now, the big distinguishing factor here is maybe not obvious to begin with. For a lot of this, it comes down to the size of the objects that we're talking about. Over in the mechanical energy side, we're looking at the motion or position of a large object, a collection of atoms and molecules, and how those things give it energy. Now, really, heat, or really thermal energy is a better term for that, but heat and thermal energy, those are associated with the motion of atoms and molecules. So it's really kinetic energy, just at a very small scale. Chemical energy is really just its potential energy, not gravitational or spring, but it's electric potential energy caused by interactions from the charged particles that make up atoms and molecules. And so a lot of this is just a matter of scale. Now, light and sound, those are clearly different from kinetic and potential from gravity and potential from springs, to a certain extent anyway. Sound is the vibration of molecules, so we could think of that as being kinetic energy. Nuclear is definitely different. This is the idea that matter and energy are really just two forms of the same thing. So we can change matter into energy, we can change energy into matter. When those processes happen, we call that nuclear energy. So this is energy that's associated with the particles within the nucleus of an atom. So now that we have a basic idea of what mechanical and non-mechanical energy are, let's look at a process where we have some change between those. So in this case, we've got a kid on a sled who starts up at a hill at zero velocity, starts from rest. He's going to speed down that hill, get to a really fast speed at the bottom here, and then kind of a sharp jolt there. That'd be a little jarring, but makes that transition, and then is going to slide to a stop as he goes on here. And we understand that there's friction between the kid and the slide, not very much, but enough that he's going to come to a stop there. So let's just look at energy types at each moment in time here. Let's do blue. So up here, he's got no velocity to begin with, so no kinetic energy. There's no springs involved in this one, so we can ignore that for the time being. And then, let's see, gravity. He's got some height up here above the lowest point that he's going to get to. So we could say he has gravitational potential energy at this point. When he gets down to this point, he's as low as he's going to get, so his gravitational potential energy is at a minimum anyway, and we can just set that value to be, call it 0 at that point, since all we really care about is changes here. But he is moving rather quickly, so we've got some kinetic energy at this point, or just K would be how you'd write that with variables. Just do that. Okay, so then we have this question of this point right here. He's not moving, and he's not up high anymore, so no gravitational potential energy and no kinetic energy. Still no springs in this problem. That would be an interesting way to sled, some way to involve springs, but not in this problem, it looks like. So we have this issue where it looks like there's no energy there compared to the energy that he had in the initial couple of phases. Well, what's really happened is there's just no mechanical energy, or at least a minimum mechanical energy. We've lost some of our mechanical energy to other forms. We know that it can't just disappear, conservation of energy and all, so it must have gone to non-mechanical energy. So we look at the non-mechanical energy types and we see what makes sense here. Hopefully while you're sledding there's no nuclear reactions involved, so we can probably cross that off the list. Sound might happen there. We can hear somebody sledding. Probably not any chemical reactions going on. Probably not going to really generate any light from this, or at least no visible light. We'll probably come back to that. And once we've talked about the spectrum, the electromagnetic spectrum. Heat, though, that's one that we definitely are going to be producing. We've got friction that's causing this guy to come to a stop right here. So all along the way, friction is generating heat. Just like when you rub your hands together, you can feel them getting warm. So all along here, we've got heat generated, and on the bottom of the sled we've got heat generated, and that heat is going to spread out and it's going to transfer to the air, but primarily we've got heat, or ET for thermal energy, not for phoning home. There we go. And that's going to be the bulk of it. We're also going to have some sound coming out of this, so we might show that as sound waves coming out. We can hear the sled as it goes down, that grinding sound of sled on snow. But we've had this change from mechanical energy. We started with gravitational potential energy, and then that became kinetic energy, and then that kinetic energy went to heat and to sound. And that sound energy is going to spread out to the point where we can't hear it at a certain distance. The heat energy tends to spread out as well. And so this, this non-mechanical energy, especially heat and sound, it's easy to be fooled and think that energy just disappears, because it spreads out from where it started so readily. So it's not as obvious at that point. So anyway, our energy is still present, just not in the same forms, not in the same locations as it started. This is a situation where mechanical energy, as the learning target states, mechanical energy is converted into other forms, into non-mechanical energy forms.